All right, so welcome. My name is Samara Hamze, and the voice you just heard is my colleague Gina Smith. We both work at the Wisconsin Center for Environmental Education. Gina is the curriculum and resource specialist at the WCEE, and I'm one of the energy educators at KEEP. I'll be telling you a little bit about that in a moment. And our guest presenter today is Holly Werra, who is a high school math teacher at New Berlin High School, where she's been teaching, well, she's been teaching math for 16 years. I don't know, just at that school the whole time. And before that, she was a civil engineer for 4 years. So I'm really excited about what she's going to be sharing with you. She teaches all upper level math classes, and the lesson that she's going to be sharing is one that she uses in her data analytics class. So we'll be learning about that. And she was saying when we were chatting earlier that she really focuses on making math students work on communications and becoming good communicators. And I think in the lesson that she's sharing, you'll definitely see how she draws her students towards the communication out of math as well. So as we begin here, I would like for us to please take a moment, and I would like to personally recognize that the University of Wisconsin-Stevens Point is located on the ancestral and contemporary lands of the Ho-Chunk and Menominee people. And if we could each take a moment to locate and recognize the ancestral and contemporary Indigenous lands that we occupy. Thank you. The Wisconsin Center for Environmental Ed has 2 programs in it, ourselves KEEP, as well as our partner program, Wisconsin's Forestry Education Program, and both are located in the College of Natural Resources on the campus of UW-Stevens Point. The vision of KEEP is communities making informed energy decisions now and for a sustainable future. And we are supported by the 6 publicly traded utility companies. So when we say our KEEP services provides trainings or whatever for free, it's that schools have prepaid for these things through getting electric services. So I always want to encourage teachers that, you know, when you ask KEEP for help, we're not doing it for free. It's you guys have paid for it. So ask for our help. We are here to support you, get you the resources, the connections, and so on that you need. Our overview for today's training is I'm going to kind of guide you to some sources of different types of Wisconsin data you might be interested in accessing and using in your classes. And some you may know about already. And if if I say something that rings a bell and you're like, oh, you know, I use something similar, whatever, feel free to share that in the chat, or if it seems appropriate to interrupt, you can do that. The 2 types of data are the geospatial data that are available from ESRI, as well as different types of solar dashboard data. And then I'll spend just a few minutes actually exploring the KEEP lesson that is the highlight of this, because I really want to have as much time as possible for a guest presenter to share what she's doing with her students using solar dashboard data at Eisenhower Middle School and High School in New Berlin. And throughout, hopefully we can have discussion. Gina and a couple other people are watching the chat on behalf of KEEP. And before I forget, Gina will be sharing links in the chat. So as I'm going perhaps to some different URLs, don't feel like you need to like jot it all down or take screenshots and look them up. We'll be sending a follow-up email that has the links that are shared here. And I would like to also mention that we have our Energy Educator of the Year nominations that are open right now, and Gina will share that in the chat. So that's going on until April 10th. So if you can self-nominate, if you are an energy educator, identify as that, or know of somebody who's doing some excellent work within your networks. And also in the room, in this digital room, is my colleague, Ashley Bedvig. And perhaps towards the end, she'll be able to share with you all a really cool opportunity each of your schools has to participate in the Renew Our Schools program, which would be a way for your school to start collecting energy data, not necessarily solar data, but your electrical use data. We have an opportunity for schools that is low to no cost. Onward. If I can get to the next slide. Okay, so geospatial data are in lots of different learning spaces. One of the places that that we really like to go is just our partner program. LEAF has an online map of all of Wisconsin's school forests, and this is just a screenshot of that. But if you were at the live dashboard, and we'll share that in the links afterwards, you can zoom in and you can click on a polygon and actually get information about that particular school forest, the year that it was registered, if it's a public school. You can see the different types of information that is there. Another place that we find geospatial data in a learning space is Green and Healthy Schools Wisconsin uses ArcGIS Online to, as well as Survey 123, both of which are apps of ESRI, to track data from schools, as well as the partners that are supporting schools and growing sustainability among all K-12 public and private schools here in Wisconsin. So these are a couple sources or places that data is being used. We in KEEP really like the ESRI product story maps, and we use it to tell the story of our energy educators of the year, because they're not just people, they are people affiliated with buildings, and those buildings are in places, and it's really cool you can extract from the story a lot more when you know where those teachers come from. If this were live, you could click on each of the images and get a brief bio of that particular educator's accomplishments. April 10th is the date you're thinking about right now. We also at KEEP are using ArcGIS, and this is not in story maps, but in an app called Experience. And I'm going to spend a little bit more time going into this map in just a moment, but I wanted to give you a preview. So we steward the data of all schools that have solar in Wisconsin. So the yellow dots represent schools that have solar, the purple dots are schools with solar, as well as an accessible online dashboard. And finally, Green and Healthy Schools, which I mentioned before, in addition to tracking data, they use story maps for storytelling about schools that have achieved national recognition as part of the U.S. Department of Education Green Ribbon Schools program. So again, location as well as the story of each of the schools can be seen in this screenshot here. So now, how do you actually access these data? I'm gonna jump over into my browser, and we're gonna take a look at some data that you might find useful. And let me not end the meeting. That is not what I want to do. There we go. So the KEEP lesson that I'll be sharing with you momentarily is built and modeled on GeoInquiries. So GeoInquiries is the lesson format that ESRI uses for their K-12 lessons. And it covers the breadth of content areas that a teacher might be teaching, including, and I know many of you here who might be viewing it later, are in mathematics. So they have it divided in level 1 and level 2. So these are more pre-algebra, algebra level lessons, but just so that you know that they're there, and they all use maps as a way of learning these different mathematical concepts. To learn more about GeoInquiries, we can go back here and navigate to it, but I'm just going to jump over here. ESRI actually uses story maps to teach people who want to learn about GeoInquiries. So it opens up, and this is a great tool if you want your students communicating whatever it is that you're exploring with them, Story Maps is a free product that you can use and has some really beautiful templates that are ready to go off the shelf. I'm going to jump ahead to anatomy of a geo-inquiry, and you can see you can navigate along here. Our lesson at KEEP is built along these same lines, where it opens up with the standards. It links to a map. It follows the 5 E's of engage, explore, explain, elaborate, and evaluate. It has some directions on how to navigate and use the map. That is in step number 2. It has some in-depth follow-up steps, or for students who want to go in greater depth, or instructors. And also it cross-references with some of the more commonly used textbooks. Righto. So I just want to be sure that I hit what I wanted to hit in that. Oh yeah, and one more thing. I felt like there was a third thing I wanted to say. ESRI ArcGIS is free to all K-12 schools across the globe. So I strongly encourage you, if you are not yet a school that has this, if you navigate to this page, there's instructions on licensing based on the number of users that you would have and who you would work with in your school district, so that you can have create access for your students to have the ArcGIS online available to them. And it's really fantastic. Our last presenter, so as I was mentioning, this is the last in our series of solar dashboards. Our last presenter who focused on GIS is also a geo mentor. So he's available if you're doing this or you're thinking about doing this. You could reach out to him and he can give you some ideas and pointers as well for implementing GIS at your school or in your classroom. So transitioning now over to those were that was more about ESRI, but taking a look now at also some of the data that we have here at KEEP. And I'm going to show you a bit more when we actually look at the lesson momentarily. But in this data set that we have here at KEEP, I'm going to show you that you can use it as well if you're wanting your students to access more solar dashboards. They can use our website or our layer for doing that. So I'm opening up the table that's associated with the dots that are here. Maybe I should open up the legend because that's useful too. So again, the purple dots are schools with a dashboard. Yellow is the ones that just have solar. And as I open up this and expand the table here, I already have it pre-sorted. So schools with dashboards appear at the top here. So that's what's appearing, but students might ask the questions of size of systems by utility. And we also have tried to track the funding mechanism. So over here, solar funding source, because some schools do it through grants, others do it through referendum. And most of them, we actually don't know how they figured out how to get solar on their schools, but there's different types of data, ways of approaching data and asking questions about the data as well. So that's one of the data sets that we have here at KEEP. Additional solar dashboard data that you might find useful, because Holly's going to be sharing the data that she uses with her students and how she accesses it, but their data is specific to their school, and whether or not your school has solar, you may still want to have your students do this type of an exercise. There's lots of different dashboard platforms that are out there, and from a pedagogical perspective, I prefer Solar Edge. So if I was having to put an RFP out for installing solar on my school, and they're like, what inverter, what dashboard do you want? I prefer Solar Edge, and I'm going to show you why momentarily here. But I just do want to point out, I have this already pre-selected. The search is for Wisconsin, so there's 251 Wisconsin solar dashboards that are available online that use Solar Edge. And I have it pre-sorted by power. And this is not a typographical error. Madison College actually has 2 megawatts, almost 2 megawatts of installed capacity. But not far behind it, or second, it is far behind it, but second in the queue here in Wisconsin for SolarEdge is Forest Edge Elementary School down in Dane County. And there's also towards the bottom of the list here, Eau Claire Memorial, one of the high schools east, Eau Claire Area School District, Memorial High School. So there we go. So they have 126 kW Oregon High School. So if you wanted to just look at educational buildings, even in the first top 20, there are some dashboards that we could look at. And let's just take a peek in at one of these dashboards. Is this the one? Eau Claire Memorial. Yay. For knowing my geography. Okay. Picking the right purple dot around Eau Claire. So they have SolarEdge. We just saw that in the other tab that I was looking at up here. So dashboards have just so much information on there, and you can you can let yourself loose on this and end up down a rabbit hole. And if you live with somebody, like, where are you? Because there's a lot to explore in there. But I'll quick jump over. One of the things I like about SolarEdge is you can actually see the physical layout of the arrays on a building, or even if they're pole mounted, and you can look at a particular panel in the array and get information on it. So one thing I can tell from looking at this is they don't have any snow left on any of their panels up there, because right after a big snowstorm, we'll sometimes see some of them that have gone dark because they're just not producing any electricity in the moment that I happen to be looking at it. So that's one thing that we could look at. There's the physical layout, and there's also the logical layout if you're interested in looking at the electrical engineering component of it. But then going back to the actual dashboard data, and Holly will share the types of dashboard data that she's extracting, but you can look at it over different periods of time. This is over just today, what it looked like. You can go down here and toggle and see, what was it doing 8 days ago. And from that, have your students extrapolate what the weather was like. It can be looked at over longer periods of time as well. So we can take a look at the month of whatever month we're in here, March. So we've had some today and yesterday were beautiful sunny days. That's the storm that came in, ice and snow over the weekend. So we can actually look at looking back in time, and also having students make predictions of, like, looking at the forecast and predicting what the electrical generation might be. In fact, I just saw on MISO today, they have CEDO, the Department of Energy, has a competition going on students who do the best. This is college students doing the best forecasting for electrical generation. So it ties meteorology and with electrical generation. So this is one of the reasons you might find SolarEdge data useful. And one of the best things is you can export the data as a CSV, and you then have a table that you and or your students can manipulate and ask those deeper questions of. You can even match them up and date-wise if you wanted to, and bring in NOAA weather into it and do weather-related analyses if you wanted to do that as well. I'm going to pause. I can't see you, but I will let Gina monitor the chat and see people's faces. And I'm wondering if there are any questions or ideas that have popped up.
None so far, I don't think, Samara.
Okay, thank you. So I'm going to just spend maybe 3 minutes here sharing with you this KEEP lesson that, as I mentioned earlier, is modeled on the GeoInquiry that ESRI has. All of our lessons are available to you. You can, as long as you're logged into Google, you can go in and make your own copy. We invite you to then edit it and use the parts of the lesson that you need to use to modify it as you need to. For instance, you might want to change out and use your own solar dashboard data, or a data set that you have pre-selected for your students. Our lessons have the title, a land acknowledgement. I'm sorry, let me increase the tile size here for you guys. Hopefully that's better. Slides that we suggest you remove before sharing them with the students are indicated with with an icon in the bottom right-hand corner. These are notes for you, the teacher. And then we follow the 5 E's of engage: explore, explain, elaborate, evaluate, and we add a 6 in here, extend. In each of our lessons, we feature at least one clean energy career as well, so that you can incorporate academic and career planning with the lesson. We've partnered with Slipstream, and so far have a 7 video series of clean energy careers. We're working on an 8th. And with each of those, there's also companion slideshows and lessons if you wanted to go deeper into it and ask your students to explore even further. We have additional resources that are available to you. And if you do use this resource, we ask that you also evaluate it if you could, so that we can make it, we can, participate in continuous improvement process. Going into the lesson a little bit now, if Gina, if you could share the link to the map, please. And I'm going to jump over into slide 9 and just show you what your students would see. So if you had shared these slides with your student, the student would be directed to navigate to this URL. It would open up a map, and I have it pre-opened to save us all time here. It would open up into this map. And then the next 3 or 4 slides guide the students in just the mechanics of map navigation in ArcGIS Online. So the first direction on there is to change the transparency of the values, and the directions teach them how to do that. So they're supposed to make them completely opaque. And then the directions ask the students to find their own location. So they might generally know they're somewhere here. They also might want to just navigate to it by scrolling in. I'm located in Oshkosh, so I would scroll in and turn this on, and I could then click on it and say that the solar potential for my area of Wisconsin is 3.8 kilowatt hours per meter squared. But the nice thing too is that there's not necessarily the right way to do it. There are multiple ways to get to the same answer, and we all know this as educators. So another way to get to there is to actually just type in the city I'm in and search it, and I better get the same answer of 3.8. Yes, I do, 3.8 kilowatt hours per meter squared. So that would be the first step that this lesson is asking the students to do. And then later on in the lesson, I'm going to turn that layer off, and I'm going to turn on the solar dashboards layer and zoom out. So each of these orange dots on here represents a link to a solar dashboard. The lesson itself explores solar potential. So there's lots of just gorgeous layers that are on here, and you might want to share this if you co-teach with somebody or teach in addition to math in other disciplines as well. This aligns really nicely with social studies as well as with science. We can look at global biomes. We can also look at global power plants. So where are the power plants across the planet? And then as you zoom in, there's increasing amounts of detail that are revealed to the student. Again, I think I said this, but I want to say it another time. You can't break this map. You can click around on it and everything. It is not editable by you or by your students. So explore and click away and really ask those questions and begin to draw connections between the different layers that are curated in the map. But going back to the lesson here, so each of the orange dots represents a solar dashboard. And so the student is then guided to open up the table, excuse me, and asked to find the dashboards with the greatest annual yields. So I think did I pre-sort this? I think I did. So here I would sort it descending. And so here, Sandia Heaven is the one with the greatest, and then there's 2 other that are below it. And in fact, the student can confirm that they have followed the directions correctly as they go through the slideshow, because there is a screenshot of what they should be seeing if they have followed the lesson as directed. So learning the mechanics of the navigation of the maps then opens up to you and to the students access to this really rich data set then of all of these dashboards. So we have dashboards that are available through this lesson. We have the dashboards that are available just on Wisconsin schools, as well as dashboards that are available in Wisconsin that use Solar Edge. And I think I'm going to pause there and switch back over to my presentation. If only I could remember. I think, there we go, I did it. All right, 2 screens when I really should have 3. So we looked at the ESRI resources as well as the solar dashboard. We've taken a quick peek around the lesson. Before I transition over to Holly and she starts sharing her screen, I'm wondering if there are any questions about the lesson or about any of the resources that I shared so far. Okay, so I am going to stop sharing my screen here. And before I do that, I just want you to take a peek. So Holly is going to be sharing data from her school, and these are the solar panels that are on top of the school. I hope I'm not taking the wind out of your sail, Holly. And this is from actually on top of the roof, taking a picture as they were actually still installing. You can see the boxes and the safety lines and such that are up there. So I will stop sharing and Holly can start sharing when she's ready.
All right, thank you. Again, I'm Holly Werra. I teach math at New Berlin Eisenhower, a suburb of Milwaukee. So, and one of the courses that I teach is now we call it data science now. It's a dual enrollment course that's offered with UWM. So students get UWM credit for taking it. The prerequisite is concurrent or previous enrollment in AP statistics. So they basically, if you know the structure of the AP stats class, first semester's generally more descriptive statistics, and then second semester is the inference procedures. So we go through everything but use the programming language R to do it all. And so we're kind of coming up on our midterm here. And so the midterm focuses on the descriptive statistics. And last year I had them use our school's solar dashboard for our solar panels for the district to make their presentation or their report. So I'm going to share that with you. So let me get my screen sharing here. Okay. All right, so let me know if there's anything that I'm talking about that you can't see, but I think we tested it and it should be okay. This is our dashboard, and actually before there's some of the pictures there too. I remember it was in the news when we first got them installed. Our solar panels are actually owned by We Energies. So this article is from 2 summers ago. So June 2019 was when we got them installed. Our solar panels are on both of our high schools, our high school, middle school buildings, and one of our elementary schools has solar panels on the roof and on the ground. So this is just a Journal Sentinel article. It's got some nice pictures of the installation of them. So all of the energy produced is sold back to We Energies. So the district makes money on the solar panels being on the roof. So that's kind of fun, the news article. But here's our kiosk then. So this is just there's different logins for every school. So this is our login for the Eisenhower school. And like you can see some of the pictures here it scrolls through. With home, you can see more of the pictures. So our roof is pretty much covered with the solar panels there. It's kind of cool. And just kind of the little, this is what's going on right now. And if we click on graph here, the kids, they can kind of mess around with this a little bit here. I think one of the more interesting one is if you look at the lifetime by day, and then they can really see that cyclical, producing the most energy in the middle of summer and the least in the winter when the daylight hours are shorter. And then they can adjust this a little bit. It gets, if you try to do lifetime by minute, it gets a little tough there, but they can kind of mess around with this a little bit. And then we have the option to download the CSV data. So that's what they used for their programming then, is that they import the CSV. And the whole idea of the project, and I'll bring up the project description here, is for them to just practice their skills with these descriptive statistics. So they can see the graphs on the kiosk and they know what it's going to look like. They can try to recreate them, or they have an idea of what they're trying to do then in R, or some of them just kind of came up with some stuff on their own. To be honest, some of them came up with stuff where I was like, that's not something that makes really any sense to analyze, but you used your R programming and you made a graph there, like, go for it. That's fine. So, and their target audience was the district office. And if you can't see this, I might be able to zoom in a little bit more here. I don't want to cut anything off. Okay. And so again, focusing on that communication where your goal is to clearly communicate the data to district office. So college educated professionals who have a basic understanding of statistics, but not a deep understanding. The idea being, don't get too technical. Don't use those kind of memorized statements that they kind of learn in AP stats. Try to break it down into easier terms to explain it to our superintendent, our director of communications. And also kind of telling them, like, it can be overwhelming. It's not meant to be a complete comprehensive report. Just show us what you can do and give us a little summary of something. And then the things that they'll be graded on, there's their rubric there. Trying to get creative. And once they figure out how to make one graph, it's very easy to then, we'll just import the data set from the other school and make the same graph. But try to get some variability in there, not just all the same graph for every school. And then they also submitted their code for me to check also. So that was most of it there. Any questions so far on that at all? Okay. Then I'll get into the programming. So I brought in some of their projects that they turned in. So, and I tried to run it so that they don't get stuck here in the presentation. But so this is one student's code. So they submitted the code with their project, and I went through and ran the code and just, confirmed that it ran and that it produced the graphics that they used. And so they get a lot of, the first command is importing the data, and then they do some data cleaning. And then they get to the good stuff towards the end here. So she's got some plots here. So let's see if we can get this going. Okay, so, and you can see, like, she did the same plot for all of the 4 arrays here, and then put them in her report. And she also had some of the summary statistics here to put in her report as well. So once they turned them in, I just confirmed again, it's easy enough on your calculator to do, well, I guess inside the CSV file, but it's easy enough to leave it in Excel and find these, just making sure that they're using R to do it. She had some nice ones in here, so I chose hers. Let's see. So, let's see if there's anything else here. Probably not. So once they generated all that, the same girl's report then is right here. So she put her report together, included some of her nice graphs. It's kind of a summary. There's a nice box plot there for the 4. That was one nice one. I think she also had a nice one here. And different variety of graphs. And I think, what I was saying before, there was one girl, she did a linear regression between, I can't even remember what it was, but something that would obviously be a perfect line. So it was kind of like, okay, well, that's what we were expecting, but at least she was trying different things. I know this one also had some nice plots there.
Holly, we have a question in the chat from Joseph
Okay.
King. He asked, how much programming background do your students in data science have?
A lot of them have none. So some of them, we have Java. I think our computer science, I don't teach those courses, but I think our computer science continuum is leading up to AP computer science, which I believe is Java. So they have that, but really they don't have no background in anything similar to this. So the way that the course is structured is we'll go through some of the commands in I'll show them some examples, and then they do homework that largely uses the same commands with a little bit, I would say like 75% of their homework, you could look in the notes that we did in class and replicate it just with a different data set. And then the other 25%, they kind of need a little bit more critical thinking to think about how they're going to get that done. Or I also encourage them to use the help commands in R to Google it. And, because that's what you're going to do in real life is if you're not sure how to make this work, Google it, make sure you're understanding what the commands are doing. And obviously it's not going to be the same data set that you might find an example for online, and then replicate it. And then by the time they get to the project, the plots that they're making here are all plots, basic types of plots that they've had in the homework. So now it's more open-ended. Hey, you guys have made these bar plots, you've made these histograms, you've made these box plots, you made scatter plots, you've made lines of best fit. Now take a look at this big data set that might need some cleaning to do. And they work on that for a couple weeks.
And Holly, if I'm correct, R is free open source. Is that correct?
R is free open source. Our students are one-to-one with Chromebooks. So they use a desktop emulator on their Chromebooks that our IT department has set up for them. And it's a little glitchy, but this year it's working well. So the first year I taught it, I had a classroom set of laptops, but that meant they couldn't take them home. Now they're able to do it on their Chromebooks. But if there's anything that I show that you want me to go back to, I'd be happy to. Otherwise, that's how we use the dashboards for us. And I have my midterm coming up now soon too, so I'm gonna look at some of that data that Samara shared and see if I can give them more to work with than just our dashboard. Our district, for whatever reason, I can't remember why, but the login they don't want the students to have. So for our dashboard, I need to show them all of that, and I need to download the data and put it in a Google Drive that they can grab those CSV files from. So I'd like to look at some of the free stuff, those free dashboards from other schools that they can use.
And Diane's asking, is your data science class a full year or a semester?
It's one semester, and it's always offered second semester. So they've had at least the first semester of AP Stats before they start it. And by the time we get to the end, we're doing everything that they've seen in AP Stats.
I'm wondering, has any of these reports ever actually made it to the school board for them to see what the students are working on?
I don't know that these went to the school board. They did go to the district office. So they went to our superintendent, our director of curriculum. I sent them all to her to share with everybody.
Cool.
Yeah.
Because I think in some cases, your students understand the stats just because they're in that milieu and having the opportunity to explore it more than the people who are making the decisions on which the stats come from. So.
Yeah.
Well, that's fantastic. I'm just so encouraged to see the data that we're taking the time to aggregate, being able to access it. Glad to know that there are people out there who might be able to use it as well. Like, I want to know how much electricity is being generated by solar on Wisconsin schools, but then trying to grow that percentage is right now like 3.5% of all electricity consumed in Wisconsin schools comes from solar. But got to get up there faster, and it's great having the integration of solar data into the curriculum this way. Are there any other questions, ideas?
There is another question
Percolate.
in the
Oh,
chat.
thanks. Yeah.
Can you explain more about cleaning the data? What does that look like or entail?
So I could try to bring some of the cleaning up here that they did. Trying to remember some of the stuff they did. So this command, they changed non-numeric data to numeric data. I know that a lot of it was changing the date to be the date range that they wanted to be. Trying to think of some of the other things they did. A lot of it too was just they would try to make a plot and the error would come up. So they'd figure out where the mistake was in the data. Let me see if I can find someone else. Like she added a month column. So she took all of the, let's see. Oh, this was the monthly data. So she changed all those to just be a month. So when her, let me see, this was for her Ike. Oh, she had a different file where she made the plots. A lot of it to adding columns. So adding a column for the difference in production and the estimate. So if you go back to the dashboard, one of the things that's on the dashboard, if you go to the graph, and it shows up in the data set too, is, let me get, I want a day there. That red line is the estimated amount. So, you know, looking at the days where we were over versus under the estimate. So that was part of it too. A lot of them, you know, they get the raw data and then they added columns to it to find some of that. You know, like I said, that's the difference between what was predicted and what was actually produced. Let's see if I can find any other ones here. She renamed her columns here.
So it looks like the cleaning is a lot of things that somebody, if they were in Excel, these are very manual things we would be doing, whereas they are coding for it instead.
Yeah, and I explained that to them too, that a lot of times your cleaning would be done in Excel, not in R. But they do it for the most part in R. I don't think I did too much to the CSVs before just giving them out to them.
Do they all get the same CSV then, or do they get to choose like different date ranges or whatever?
If they had a request, I did it, but for the most part, I just said, you know, and I told them to make your code so that it will run for any, you know, any data set called Ike 15-minute CSV. So when they started it 2 weeks later, there was 2 more weeks of data. So they had to deal with that too. How do I make it so that it's more generic code so that it can take any data set with, you know, reasonable date ranges and plot it? And I'm not saying, you know, it's going to plot it ending March 14th. You know, it's going to, now when it goes to March 19th, I can import that same data set and make a similar plot that's just a little bit longer now. So, but if some of them, if they had a specific request, I know that like the 15-minute data sets got really long. And I think that even they had some problems with importing them. So a lot of them stuck to just days for 1 year, or they switched to months or weeks to make it a smaller data set.
Cool. I'm wondering from those who are attending, if any of you have used similar data or other data sets and how that's worked for you, or if this has sparked ideas of how you might want to use data. I'm taking a look at the time here, and we are happy to stay on at least till 5 o'clock. These other sessions have gone at least that late. But before we end here, we do have couple more slides from Keep that we would like to share with you. So Holly, I'm going to take over and share my screen again, if I may. Thank you so much for sharing with us what you're doing with your students. It's super exciting to know that we have students coming to college who already have those experiences as well. Let's see here. All right, so we'd like to share some other opportunities that Keep has for you now and into the near future. If you'd like to explore the lesson that I gave a brief overview of more deeply, we have an online self-paced course that you can register for. If you use this code Keep for Teachers 22, you can take it for free instead of paying the $25 for the cost of the course. I'm going to skip this one, and I'm going to let Ashley talk about Renew Our Schools in a moment. We're also sponsoring up to 15 teachers to attend the MREA Energy Fair, which is happening the third weekend in June for free. And so if you read our next newsletter that's coming out at the end of the month, there will be more information on doing that, but it'll be also code-based. There'll be 15 people who can use that. And Create, which is an NSF grant that Madison College has for teaching high school and tech ed college instructors about solar installation and the use of solar, has an in-person Solar Institute coming up July 12, 13, and 14 in Madison, and they're currently taking applications. I think Gina's sharing the link for that in the chat rather. And if you do decide to go, I strongly encourage you. I would love it if you could go as a team from your school, maybe yourself, somebody from tech ed. And if you can get a school counselor who maybe even can go for just a day. We are desperate for our students to know the breadth of energy careers that are available to them. We have a huge retirement up ahead in all parts of energy careers. And so we are working to recruit students to be interested in that. And it goes everywhere from data to the students who like to be outside and climb poles and work with their hands and the full spectrum. So that would be a great opportunity. I'm going to hand it over to Ashley to share a little bit about Renew Our Schools and what that could be.
Hi, everyone. My name is Ashley and I work with Samara at Keep, and my job is kind of running the Renew Our Schools competition. This is a national competition where schools sign up and they get an e-gauge installed on their school building. And so it measures how much electricity you're using throughout the day. And we collect a lot of baseline data. And then there's a 6-week competition in the fall and the spring where you compete against all the other schools to reduce your energy consumption. And you do a lot of energy education-based activities to earn points. And the school that has the most points and reduced the most over the 6-week competition actually wins significant money that they can use towards building improvements for their school or energy efficient updates. It's a really great opportunity to get your students involved in some of this energy education. It gets them some data that they can work with that you can incorporate into your curriculum. So I will drop the link again in the chat. If you guys are interested, we're recruiting for the fall competition right now, which would be October 3rd through November 11th. And we're asking that schools sign up by March 31st of this year so that we can coordinate the installation of the e-gauge and collect enough baseline data so that by the time the competition starts, we have something to work off of for energy conservation. We have 9 schools from Wisconsin right now in the competition, the spring competition that's going on. This is actually the last week and it's been going really good and the schools have really gotten into it. So if you guys are at all interested, there's an inquiry form that you guys can fill out and hopefully we can get more schools represented in this national competition.
It's really a great opportunity, whether or not your school has solar, to get some great energy usage data, and your school gets to keep the e-gauge, which it's like a $1,200 piece of technology between the hardware and the installation that goes with it. So it's a great opportunity, and Focus on Energy has partnered with us, and they're covering the majority of the cost as well. And the very last ask we have of you is, if you have your phone nearby, you can take a picture of the QR code that's on your screen, or Gina's sharing, I think, the link in the chat as well. It's a very short survey, but if you could evaluate this training, we would love to hear back from you as well. So we thank you all so much for the time that you've given us this afternoon. We thank Holly so much for taking the time and sharing what she's doing so generously with all of us as well. And as I mentioned earlier, we'll be following up with an email that has a lot of the links there. And anybody